Problem 37, we have this circuit has been connected for a long time. It's very important, long time. It means that the capacitor takes a long time to be charged at t equals to infinity, long time. In this case, the capacitor will be charged to Q max. When we have Q max, at this time, I at t equals to infinity equals to 0. Okay, I send you many video about this, about charging and discharging capacitor. So at a long time here we don't have I equals to 0. Let me simplify the circuit. Look, here we have the volt 10. This point is the point A. Okay, we can say A and A. We have nothing between. We have the same point, A. And this point is B. We have B and B. And here we have C and D. So we have C and D. I need to calculate the potential difference across the capacitor. So we have to find VCD, the value of VCD. Look, you know the current created by the battery. Let's say here we have the current will be up. At this point, in a part will go through this wire and a part will be down. As we don't have current here, so the current will continue down, the same value. And here also you will have the current like this. And here we have current in and out. So here we have I, let's say small I. Here we have I. Let's say this one is I1 and this one is I2. Okay. You see here as this wire, we don't have a wire here, so it can be considered as disconnected. We can find I2 as the voltage. Here we have A and here B. So this one and this one can be considered as in series. Okay. So R equivalent, we can say 1, 2. R equivalent 1, 2 equal to the summation equals to 5 ohm. And the same for 3 and 4. R 3, 4 equals to 10 ohm. Okay, 8 plus 2. As we have the voltage delta V of 1 to delta V between A and B. So here we get a new image if you want. Here we have 1 and here we have two equivalent, R1, 2, and here we have R3, 4, plus, minus. Here we have A, B, and here also we have AB, the same. Okay, we can calculate delta V. You know delta V is equal to 10 for each side. We can find now I2 and I1. You know, we can take, first of all, R1, 2, delta V of 1, 2 equals to 10, which is equal to R1, 2 times I2. So I2 equals to delta V 10 divided by R12 equals to 5. So I2 equals to 2 ampere. Okay? The total is 10. We have 2 ampere here. So here we get 8. We can say here we have I equals to I1 plus I2. We can calculate I1, which is equal to we don't have the value of I. Okay, let's continue. We take now R3, 4. Delta V 3, 4 equals to 10 equals to R3, 4 times I1. So I1 equals to 10 divided by R3, 4 equals to 10. So I equals to I1 plus I2 equals to 1 plus 2 equals to 3 ampere. Okay, we come back to this figure, figure B. We calculated I2 here and I1 here. Okay, now it's easy to find delta V between A and C. Okay, because anyway, I need to calculate the potential across the capacitor. I need to calculate VCD. In this way, we can take a loop, for example, this loop here, and we can apply junction rule. So we take a loop A, here we have A, D, C, A. Also, you can take the lower loop, you get the same result. So we take A, D, C, A. You know, summation of delta V equals to O. We take delta VAD, delta VDC, delta VCA. So delta VAD plus delta VDC plus delta VCA equals to O. So VD minus VA plus VC minus VD plus VA minus VC equals to O. We come back to this one. You know, here we have positive and here we have negative. We start by positive and we go to the negative. Here also, we start by plus, we go to minus. Okay, here, you know, I2 is down. Okay, I2 is down. So we have plus and minus. Okay, we have a clockwise loop. I need to calculate delta V DC. Okay, delta V DC on the capacitor. This one. So we can keep it delta V DC. Delta V DC. We look to VD and VA. VD, we start by A, we go to D. D is at the negative side, so we have minus. The potential of the resistor equals to 8 times I1. Here we have I1 plus delta V DC and okay, DC, and now we come to CA. CA, V at A is positive. So we have plus. The voltage here equals to R times I. Here we have I2 equals to 0. So delta V DC equals to 8 I1 minus I2 equals to 8 times I1 equals to 1 minus I2 equals to 2. So we get the final answer will be 8 minus 2 equals to 6 volt. Delta V at the capacitor equals to 6 volt. Okay. Now, if the battery is disconnected from the circuit, okay, now we disconnect the battery like this. We can say like this. Over what time interval does the capacitor discharge to 1/10 its initial voltage? It means how much time I need for the capacitor to lose V at the time t will be V initial divided by 10. Okay, I need to find the time. Okay, here in the last videos I send in the case of discharge capacitor Q in function of time equals to Q exponential minus t divided by RC, and I in function of time equals to minus I initial exponential to minus t divided by RC. So here you know V equals to Ri. If we multiply by R and here by R, we get, okay, this is in the case of discharging. Discharging. Okay. So here we have R times I t equals to minus I initial times R exponential minus t divided by RC. R times I equals to V in function of time equals I initial times R equals to V initial times exponential minus t divided by RC. So what I have to calculate the time t where V initial, we can say here Vt divided by V initial equals to 110. Okay, I have to find t. So we continue here. We can say V, we can take this one, Vt divided by V initial. We put this down equals to minus exponential minus t divided by RC. Okay. Part B, if the battery is disconnected from the circuit. I mean, here it's disconnected. So we don't have this wire because it's disconnected. Over what time, we have to find that time interval does the capacitor discharge to 1/10 its initial velocity. I have to find the time where V at this time equals to V initial divided by 10, or we can say V at this time divided by V initial equals to 110. We calculated in the last videos, in the case of RC circuit, if we have a capacitor plus a resistance C, and here we have R, we calculated Q in terms of T, and I also equals to Q initial exponential minus T divided by RC. You know, if we have a point A and here we have a point B, the voltage at the capacitor equals to the voltage at the resistance. Okay, so if we divide by for example by C, by the capacitance, and here we divide by the capacitance, you know, Q divided by C equals to V as the time t. And here also Q0 divided by C equals to V initial exponential minus T divided by RC. So Vt divided by V initial equals to exponential minus T divided by RC. Okay, this is the relation of V in terms of time. Okay, we come back to this case. Here we have to transform this circuit to RC circuit. Okay, here let's say we have A and here we have B. So between A and B we have two resistors in series. Here we have 1 and here we have 8. And also here we have 4 and here we have 2. The equivalent here will be 9, the summation 9, and here will be 6 between A and B. And also the equivalent between A and B, this one and this one are in parallel. We can find the equivalent. So we get finally this circuit. It's a RC circuit where V at the time t equals to V initial exponential minus t divided by RC. In this case, R is R equivalent. Okay? You know, to calculate R equivalent equals to 9 times 6 divided by 9 plus 6. We calculate its value, which is equal to 3.6 ohm. Okay, so here we have Vt divided by Vi. I give you equal to 110 equals to 110 equals to exponential minus t divided by RC. You have to know this relation, V in function of time. Okay? So, to calculate this one, we put len 1 divided by 10 equals to len of exponential minus t divided by RC. You know, len exponential A equals to A. So this one, we can say here equals to minus t divided by RC. Okay? So we can write len 1 divided by 10 equals to minus t divided by RC. We can put here plus, here minus, or you can keep it. So here we have minus t divided by RC. We can put the minus here. You know, minus len x equals to len 1 divided by x. Or we can say len x equals to minus len 1 divided by x. Okay? So we can write minus minus ln 1 over 10 equals to ln 10 equals to T divided by RC. So T equals to RC ln 10. We have R equivalent. We calculated its value. So here R times C equals to, I have the value of C also, okay, equals to 1 microfarad. So here we get 3.6 times 10 minus 6 times ln 10 equals to 8.29 microsecond is the time needed to lose half of its voltage. Okay,